Okay, now I'd like to talk about even and odd functions and their symmetry. So even functions are functions that look like y equals x squared or y equals x to the fourth. And so they have the property that f of negative x equals f of x. So it doesn't matter if you plug in negative x or x, you're going to get the same thing out. And you can think about x squared. If you put in negative x, you get x squared. And if you put in positive x, you get x squared. And so they have the property that they are symmetric about the y-axis. And so you can see here that if you plug in like negative 2 or if you plug in positive 2, you get the same y value. And so you get this symmetry across the y-axis. So essentially you could spin this graph around the y-axis and it would land right on top of itself. Now odd functions, you should think about like, you should think y equals x cubed. That's an example of an odd function, or y equals x. These have the property that f of negative x is equal to negative f of x. And they're symmetric about the origin. Or 0, 0. So in this picture you can see that, let's see, this point right here, that would be f of 1 is 1. That's equal to f of negative 1, which is negative 1. So there's just symmetry across the origin here. And here is 2, 8, right? And negative 2, negative 8. So there's a symmetry through the origin. Okay, and now there are easy ways to see if a function is odd or even or neither. The easiest way is you just look at the powers that are showing up as exponents, and if they're all even, then the function's even. If they're all odd, then the function's odd. So in this case, we have x cubed minus x to the first. And so this is an example of an odd function because all of the exponents are odd. And that's important. You need all of the exponents to be odd for this to be an odd function. Now the second example is neither, and that's because you have one even exponent, which is the x squared, and you have one odd exponent because this is x to the first. So this is neither even nor odd. Okay, and then finally this last one, you see you have 2x squared and x to the fourth. This is going to be an even function because both exponents that are showing up are even. So this is an even function. So h of x is an even function. So f of x is odd, h of x is even, g of x is neither.